Hello everyone, welcome to my class. Today we are covering section 6.3, volume by cylindrical cells method. So let me start the class right away. Cylindrical cells method is an alternate method to disk and washer method to compute the volume of a three-dimensional solid. In this method, we find the volume of a solid by dividing the solid into a bunch of concentric cylindrical cells centered about the axis of rotation. The cross sections are taken parallel to the axis of rotations. Keep in mind, in disk and washer methods, our cross sections are perpendicular to the axis of rotations. So now formula: volume equals to definite integrals of 2 pi x fx from a to b for rotation about y-axis. So here, when you rotate the regions under the graph of fx between x equals to a to b, then our radius of the cylinder is x, the distance from axis of rotations to the outer surface of the cylinder. In general, if our region is bounded between two functions, then our volume is definite integrals 2 pi x top curve minus bottom curve, or right curve minus left curve from a to b. Similarly, if our rotations is about x-axis, then the volume formula is definite integrals 2 pi y fy y equals to c2d, and in general, volume equals to definite integrals 2 pi y, so fy minus gy from y equals c to d. Great. So let me derive this formula very quickly. So the idea: consider a solid obtained by rotating about y-axis the regions bounded by the curve y equals to fx, x between a and b. So in the first diagram here, this is the functions fx and x between a and b, and we are rotating these regions under the graph of fx above the x-axis bounded between a and b around the y-axis. So we are rotating this region around the y-axis. So in the second diagram, we got these cylinders here. The idea is take a stripe on the regions and swing around the y-axis. So then this generates a cylinder here. Similarly, this whole region generates this big cylinder here. I hope this makes sense to you all. And then in this cylinder here, the height is this one, which I denote by h. This h is just a function's value here, y equals to fx. The width of this stripe is dx, that's the thickness. So we are integrating with respect to dx. The radius of this circle here, or this cylinder here, is the distance from the axis of rotations to the function, which is x. Then in the third diagram, let's cut this cylinder and line it out flat. Then this gives me this rectangle here, rectangle shape. So whose length is 2 pi r. This is just the circumference of our circle, 2 pi r. Keep in mind our r is x, and this height is this height, which is fx, and this thickness is this thickness, which is dx. So we can easily compute this volume of this rectangle here, or this elementary cylinder. So our volume is area times the dx. Area is length times the width, so 2 pi r times the fx, and multiplied by dx gives us the elementary volume. So dv equals to 2 pi x fx dx. Then we can repeat this for each of the stripe here. So that means we take a definite integral. So definite integrals gives me then our volume of this big cylinder here. So volume equals to then definite integrals of 2 pi x fx dx, x equals to a to b. That's what I have here. Great. Now in general, if our region is bounded between two curves, then our volume formula is definite integrals 2 pi x fx minus gx, x from a to b. Great. Now similarly, if we rotate the regions around the x-axis, then our volume formula will be the v equals to definite integrals now 2 pi y. So this times my radius of the cylinder will be y, then fy dy, where y equals to from C to D. In general, if our region is bounded between two curves, then our volume is definite integrals 2 pi y times fy minus dy, y equals to C to D. Great, now let's move on. So you may be wondering, why do we need this method, cylindrical cell method? So let's observe one example quickly. It's example 0. Consider the problem of finding the volume of a solid obtained by rotating about the y-axis the regions bounded by the curve y equals to 2x squared minus x cubed and y equals to 0. Great. So let's move on. So first solve these two equations here. Y equals 0 is the x-axis. So let's solve these two equations, then we know where they intersect. So the very first one here, we solve 2x squared minus x cubed equals to 0. So factor x squared out. So 2 minus x equals to 0. So that means either x 0 or x minus 2 equals to 0 implies x equals to 2. So they meet at 0 and x equals to 0 and x equals to 2. So then this gives me this nice bell-shaped region here. So the question is, let's rotate these regions around the y-axis, then this generates a solid, and let's compute the volume of that solid using Wasser method and Schell's method. So in Wasser method, here is a problem. To compute the outer and inner radius of the washer, we'd have to solve the cubic equations. For x in terms of y, that's not easy. So when we rotate around the y-axis, then I need to find this radius here. So inner radius and outer radius. Then I need to solve this equation in terms of x. So that's not easy. Fortunately, we have a cylindrical cells method. Let's see. So cells methods. Now we are rotating these regions around the y-axis. So first we take a stripe and rotate this stripe around the y-axis. So this generates this tiny cylinder here. And same as if I rotate the whole region, then this generates the big cylinder here. Okay, so I hope this visualizations make sense to you all here. So now let's talk about this tiny cylinder here. So here is the height is, which is h given by the y here, which is y equals to 2x squared minus x cubed. The radius here, radius of the cylinder, is the distance from the axis of rotations to this curve, so which is simply x. Thickness is dx, so we are integrating with respect to dx. Then in cylindrical cells methods, our volume is the definite integrals from 0 to 2, right? And then 2 pi r h, that's the formula, right? So 2 pi, this is constant, r radius is just the x distance here, and then height is y, which is 2x squared minus x cubed. Great. Look, the setup is easier as well as computation is also easier. Now we can easily evaluate this definite integrals. So 2 pi pull outside, then first multiply this x inside, so 2x squared times x is 2x cubed, then take integrations, 2x to the power 4 over 4, then minus as it is, x times x cubed is x to the power 4, so the integral of x to the power 4 is x to the power 5 over 5, and from x equals to 2. Then plug x equals to 2 upper limit minus x equals 0 lower limit and simplify. It gives us 16 over 5 times pi. Great. So I hope this may answer your questions why you need to study cylindrical cells method. Great. So now let's move on. Now let's do some examples computing the volume using cylindrical cells method. So first example, find the volume of the solid generated when the regions under the curve y equals to radical x between x equals to 0 and x equals to 2 by rotating about the x-axis. So always sketching is helpful, so let's sketch the region here. So the region is between y equals to radical x, y equals to radical x, this is y equals to radical x, between x equals to 0, so between x equals to 0, so which is y-axis, x equals to 2, this particular line. So we are rotating this region here, this region which is under the graph of y equals to radical x above the x-axis bounded between 0 and 2, and we are rotating around x-axis, right? Okay, so then this region, when I rotate around the x-axis, so this generates this cylinder here for this stripe as well as for the big here, for this big region we do have a big cylinder here which I didn't draw here. I hope this idea makes sense to you all. Then let's talk about this elementary cylinder here. So what's my height here? Our height is, so from here to here, so that means this is x equals to 2 minus the x is coming from this equation. So let's solve for x, so then x equals to y square, so this is 2 minus y square. I hope this makes sense to you all. And then thickness is dy, so I'm integrating with respect to y. And my radius, what is the radius of the cylinder? The distance of this stripe from the axis of rotation, so then this distance is simply y. No matter where this stripe is, here or here or here, it's the y. Y is radical x. So let's talk about the setup part. So volume equals to definite integrals, the 2 pi r 8. That's the formula, right? So 2 pi, what's my r? R is y. What's my h? Height is this one, which is 2 minus y square, 2 minus y square. And y goes from here to here. So here is a 0, that's fine. And what is my upper limit for y? So it's up to this point. So here, this is my x equals to 2. So put x equals to 2, then y equals to, this intersection point is y equals to radical 2. I hope this setup makes sense to you all. Now let's move on. Now let's evaluate this definite integral. So the next step, 2 pi pull constant outside, send this y inside the parenthesis, so 2y minus y cubed and dy, again y from 0 to radical 2. Let me scroll down. The next step, 2 pi as it is, integration of 2y becomes 2y square over 2, so 2 cancels, minus y cubed becomes y to the power 4 over 4, and put limit 0 to radical 2, and now simplify this one, then this gives us 2 pi. Great. And just for the quick reminder, this example we did in section 6.2 using disk method also, and answer is the same. Awesome. Now let's move on. Example 2 is better. Find the volume of this solid generated when the regions bounded between the curves y equals to radical x and y equals to x square by rotating about y-axis. So I'm using two functions here, so that means in my height I need to subtract. Okay, great. So first let's draw the region here. So here is fx function is y equals to radical x, is this one. Another function is gx equals to x square, it's y equals to x square, this parabola. Then first I need to find the point of intersection, so let's solve these two equations. So set radical x equals to x square, square both sides, bring x to the power 4 to the left and factor the x out. So then the product of two numbers equals to 0 implies either one should be 0. So either x 0 or 1 minus x cubed equals to 0 implies x equals to plus minus 1. But I'm only interested in the plus part here, so this is the point of intersection here. So 0 and 1. And we are rotating these regions around y-axis. Great. Now what's the idea? Take a stripe on the region. So we take this stripe. This stripe is a parallel to the axis of rotations. So keep in mind, in washer method, we take a stripe perpendicular to the axis of rotations. And in cylindrical cell method, we take a stripe parallel to the axis of rotations. I hope this makes sense to you all. So then now let's rotate this stripe around the y-axis. So then this generates this cylindrical cell here. So the width of this stripe is dx. So what's the height here? So height is here, from here to top is fx, and from here to here is gx. So this height is simply from this big distance minus this small distance. So fx minus gx. So then radical x minus x square. What's the radius? Radius is the x distance, right? No matter where we pick this stripe here. So this is simply the x, and our definite integrals is with respect to x, so from 0 to 1. I hope this explanation makes sense to you all. And now let's use general method in cells method. So that means using our height, the difference of the two functions. So then formula is v equals to the definite integrals x equals to 0 to 1 2 pi, I need radius and then I need height. So 2 pi r is x, this distance, and that's my height, so which is radical x minus x square, which I found here. I hope this setup makes sense to you all. Let's move on. Then let's evaluate. So pull 2 pi outside, definite integral, send x inside, so x times x to the power 1/2. Radical x means x to the power 1/2 is x times 3/2 when you multiply this x inside, minus x times x squared is x cubed dx. Great. Then in the next step, 2 pi as it is, integration of x to the power 3/2 is x to the power 3/2 plus 1 is 5/2. So x to the power 5/2 dividing by 5/2, which is same as multiplying by 2/5, right? Minus x cubed becomes x to the power 4/4 and limit from 0 to 1. And now put the value x equals to 1 and simplify. This gives you 3 pi over 10. We don't need to put lower limit because lower limit is 0, so everything is 0. So only upper limit, simplify, gives you 3 pi over 10. That's the volume. Awesome. Similarly, let's move on. Let's do another example. Example 3. That's better. Okay. Find the volume of the solid obtained by rotating the regions bounded by curves y equals to x cubed, y equals to 8, and x equals to 0 about x-axis. So let's begin the solutions. First draw the region. First draw the region as well as solid. So what is my region here? Y equals to x cubed. Oh, here. Okay, y equals to x cubed. First diagram here. Y equals to 8, horizontal line, and they intersect here. I don't know what point is this. This is maybe when x is 2, y is 8, so this is 2, 8, okay. and x equals to 0, which is y-axis. Now we are rotating this region around x-axis. So we are swinging around the x-axis. So then how to generate the cylinder there? So the idea is draw the stripe in the regions parallel to the axis of rotations. So this stripe here, and swing around that stripe to the x-axis. Now that generates a cylinder. Okay, so that's what I did in the second picture here. Now the same region, this one and this one here, and I take a stripe and then I swing around the x-axis. So then this generates this cylinder here. What's the width here, which is dy, right? This stripe's width is dy, so we are integrating with respect to y then. And what's the height here? What's the height here? Height is the x value here, right? Because how far from this y-axis. So the x, what is x? I need to solve for this equation, y equals to x cubed, gives me x equals to cube root of y, this one. And then what's the radius here? The radius of the cylinder is the distance from the axis of rotations to this stripe, so which is y value, right? Great. So now I hope this description, this diagram makes sense to you all. So let me move on. Then in cylindrical cells method, our volume setup is v equals to 2 pi different integrals. We are integrating with respect to dy, so y limit are 0 to 8, 0 to 8. And then 2 pi r 8. What is my r? R is a height. Height is y. And then 8. 8 is now the, I do have these two functions here. So then this height that I mentioned, I will mention here, which is cube root of y. And I don't need to subtract here, so just get cube root of y. So cube root of y and dy. Awesome. Because the two curves here, y equals to x cubed and y equals to 0, so that's why I wrote 0 here, so that you understand we are using in the general formula of this cylindrical cells method. Awesome. Now let's evaluate. So in the next step, 2 pi as it is, and the definite integral again as it is. Let's FOIL this one first. So is a cube root of y is same as y to the power 1/3 times y is y to the power 4/3, because we are adding the power. Y power 1/3 plus 1 is y power 4/3, and then 0 is 0 times y is 0, maybe tiny is 0. Now let's evaluate this integral at the end. So the 2 pi as it is, so the definite integral of y to the power 4/3 becomes y to the power 4/3 plus 1 is 7/3 divided by 7/3, which is same as multiplying by 3/7. So that's why this 3/7 is coming from. And evaluate y equals to 0 to 8. Then put y equals to upper limit 8. Lower limit is 0, by the way. Then simplify. It gives us 768 pi over 7. Awesome. So we finish this example, as well as we finish these sections. Thank you.